Okay, hello students. Here I am on Algebra 2, Unit 4, lesson number 7. So this lesson is about interpreting and using exponential function. So the learning target, the learning goal for this is comprehend the term half-life in relation to the radioactive decay of certain elements, that's like carbon, sodium, and use it to calculate the age of different objects. So how are we going to do is describe the parameters of exponential expressions that represent different decay situation. So every each every student can use half-life of elements to calculate how much of the element remains over the time. So basically half-life is when radioactive, let's say carbon 14, basically it takes 5,730 years for any um, grams of substance to change to half of the size. So we'll take straight away some problems. And as I said, so in the Desmos activity, we did completed the lesson uh, task 1. So there was a question on a colony of microbes doubles every 6 hours. Explain why. We could say the population grows by sixth root of 2 every hour. So there's the groups of 6 hours. So just a quick one example, a colony of microbes doubles. So what is the meaning of doubles? That means the growth factor, let's say B, is 6 for every 6 years. That means if you try to draw this, it means in the beginning, whatever that, let's say 0, but in 6 years, 1, 2, 3, 4, 5, and 6 years, for the jump from 0 to 6, so the factor that multiplies is 2. So this could be A naught. So that means this is twice A naught, which means it doubles. So the question is how, actually why we could say that the population grows by this every hour. Sorry, this is in 6 hours. So this is not a day, it's 6 hours. And clearly we need to know for every hour. So from here to here, so then from here to here, from here to here, then from here to here, from here to here, from here to here. So we want to know for everyone, right? So because let's call this as B, so we have to B. So factor B gets multiplied 6 raised to B raised to 6 will give you the two doubles. And naturally by writing square 6 root of 6 both sides, we get the answer is 6. So we get 6th root of 2, which is also can be written as 2 raised to 1 over 6. And that's the growth factor for each each hour. Okay, so that's all that means. So let's go dive down directly to the practice problem. Mm, let's here it is. The first question for the day. So the first question for problem number 1, practice problem, is half-life of carbon 14 is given so many years. That means when we try to draw, it means in the beginning, a fossil had 6 picograms. So that means in the beginning 0, it was 6 picograms of carbon 14. Now, what is 1 picogram? Is 1 trillionth of a gram. That means this much. See? So that's so little it is. Which expression describes the amount of carbon 14 in picograms T years after it was measured to be 6 That's the beginning, right? It's in the beginning. I call it A naught in the beginning. That means in somewhere here, let's see, let's put it something like from jump of 5,700. So 5730. This 6 picograms becomes 3 picograms. That because it becomes half. So it's like you're multiplying by half. So the decay factor here is half from there. So this is first input is number of years, the number of years. So number of years, and this is the amount of, let's see, you can even call it as uh, A of t, A of t. Now the question is, which expression describes t years after it was measured? So we want to know, now this is for every 5,700. So we'll have to split now. We want to know for every year how much. So 5,000, we'll have to split this in almost so many 5,000 years. This have to look like this. So we want to know, we'll have to use a magnifying glass to say, that means for 1 year, like 1 year. So that B, so we have to multiply B, like there is a fact. We want to know what is that factor for 1 year. So and so on. How many times? 5, 7, 3, 0 in order to get this half. So that means B raised to 5,730 is half. So the B will be taking both side. So both side take 5,730 on either side, 1,507 and 30. So this becomes your factor in 3 years. So the expression will be in the beginning. In the beginning, remember the formula is exponential function A naught is the beginning and B raised to x. X is increment of 1. So x stands for 0, 1, 2, and so on. So this part is the 6 picograms, so that's 6 times. I can use the A of t. T stands for number of years since it was first seen that it was 6 picograms there. And now this is the factor, so it is half raised to 15730 raised to t. And that could be written as, this t gets multiplied here, and you get 6 times half raised to t over 5, 7, 3, 0. And that's the expression. You see the answer is the first one. Okay, so I want you to make sure you understand this and write all this note how it works so that you really understand how to figure out how do we write exponential function in this real world situation. Okay, let's go to the next one. Okay, the second question. The half-life of carbon-14. Again, the same kind of a question they are talking about, speaking about carbon-14. Uh, so a tree fossil was estimated to have about 4.2 picograms when it died. That's the beginning, right? So if you make a table, that means again in the beginning it was 4.2. So I'll write 4.2 right here. Okay, and then after 5,730 half-life. So here, this is 5,730. So from here, it's multiplied by half. Uh, so this will be 4.2 will change to half of it. That is, half of 4.2 will be 2.1. Right? Now let's go for, so this is 5,700, and the question is the fossil now has about this much. So if this much is there, somewhere around, it is around 0.5. Now we can just work out this another group of 5,730 years. This 2.1 will be again multiplied by half. That will be 1.05. Again multiplied by half. So that will be turn out to be half of this 1.05 will be 0.0525. So this is like from here, this is 5,000, then again 5,000, and again 5,000. So you can see this is almost like asking you how many years it is, right? And you can clearly see you get 0.5, which is the same as here. So how many years you see? So this is 5,700. So again 5,730. So three groups of 5,700. So it's going to be 5,730 multiplied by 3 times. So 0, 9, 1, 2, 15, 16, 17 years. So after so many years, this 4.2 grams of uh, picograms will change to half, 0.5, half. So it takes a groups of one group of 5,300 years, 730 years, another group of 5,730, another, so three of them. And that's why you need to multiply by 3 and you get the answer. Hope that helps as after so many years, the amount of picograms is half is this much. Let's go to the third question. Okay, the next substance used in nickel 63 is a radioactive substance with a half-life of 100 years. So this is 100 years. An artifact had 9.8 milligrams of nickel when it was first. So we'll have to make a table again. That means in the beginning it was 9.8. So I'm putting 9.8 milligrams of nickel. So uh, this is about, so the T is here. So this is T. Okay, this is T. And this one, let's call it as f of t. So we want to know the first question here is T years. We want to have an expression for that. Now in 100 years, from here to here, let's say in 100 years, so 9.8 will become half, which is 4.9, right? So the question is, so every year, so in 100 years, this will be like 50, then 25, 75, and this 25, which is you'll break them into 25 pieces here. See, like this you go on splitting this into. So each one will be, yeah, this will be. So how do we write this? So your FT, the formula FT is the F2 stands for amount of nickel substance remaining in milligrams equals in the beginning. Now the formula, let me write the formula again. The formula is f of the y exponential function, whatever you have in the beginning, times b raised to x. But this x is 0, 1, 2, 3. But in this example, they give you 100 years, right? And if you want to do for only 1 year, so the formula changes to, so what you had was 9.8 times half growth factor is to this formula. This b is half. But then because the amount becomes half after 100, it gets reduced by half after 100 years. So the number of years t has to be divided by 100. And clearly see why this is true is if you put t equals 100, and you can clearly see that 9.8 times half, you replace t by 100, so 100 and divide by 100 is 1, and you get half of this is 4.9, and that is true. You can clearly see this is true here. So this makes sense. The second question is asked is, what about in days? Now, this formula that we did was for ft. So I want to know for, let's say, another use an expression in g. and we want to know in days. So how do we change this? Now, years, 1 year is 365 days, right? So that means the number of days depends on 365 times how many years pass in this part. So we can divide this by 365 and this becomes 365, right? And replace this. So this t, you plug it right here. So therefore, this will become, so I'm going to write it right here. So 9.8 times half raised to, and I'm going to replace this by t. So the denominator is 365 gets multiplied to this 100. So so that will reduce to 100 times 365. So your answer will be, final answer is 9.8 times half raised to the d. I missed that d, right? You're replacing this by t by d. So it is d divided by 36500. So that's the expression. To know each day um, uh, uh, how much milligrams of nickel stays in the dead tree after so many, yeah, whatever the days are given to you. So hope that helps. Let's go to the question number 4. Tyler says this expression. Now look at this expression. The moment I see this, what I'm going to write is this is f of x is, there's no number before the exponential uh, part. So it's 1 times 5 raised to x, right? Is an exponential function. And so it grows by equal factors over equal interval. He says that the factor this for an interval of 110 because 10 of those intervals makes an interval of 1. So I want you to stop this for the video for a while and think of, do you agree with Tyler, and see if you can do it by yourself. Okay, let's move on. So I will make a table this way. Okay, and let's see, in the beginning it was 1, and then from 0 to another 1, let's see, from 1, and you can see the factor is 5. You can clearly see that this x is 0, 1, 2, 3, 4. That means from here to here in 1, when x is 1, you are going to multiply by 5 because there's a 5 here, right? So growth factor is 5. So it becomes this one, which is right here, gets multiplied by 5. So this will be 5. And then 2 will be, again you multiply by 5, will be 25. 3 will be, again you multiply by 5, will be 125. Now the question is, uh, so the Tyler says it grows equal factor over, he says that the factor must be this. Now what does that mean? 10 root of 5. What does this mean? Is 5 raised to 1 over 10. So basically what it means is, this is 5, right? This is 5. So I'm going to split this into 10 parts. Okay. Sorry. So let me split this into 3. Okay. So 1, 2, 3, 4, 5, and then again I split this into 5 more. Okay. So he's saying this factor will be for, so he's saying for 1/10 of it. So this is, from here to here is 1/10 because this is 1, right? This is 1. So this from here to here is 1/10 of interval. Then 2/10, then 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10, and 10/10. So I think so 10 of those will give you this one here. So I want to repeat this if there's a confusion. So from here to here is 1/10. So it is 1/10 of of 0 to 1, then 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and 10/10, which is 1. So this is 10 divided by 10. So that means what is the factor here? So this will be the right answer, because if you see this from this part, it is 5 raised to 1 over 10. Because when you multiply 5 raised to 1 over 10 times 5 raised to 1 over 10 multiplied by 5 raised to 1 upon 10, and then you do 10 times, so this means it is 5 raised to 110 plus 110 plus 110 plus, and you add 10, 10, 110, which is same as 5 raised to 10 over 10, and you get 5. So it's correct. So that means Tyler is correct, because from the jump from 0 to 1, the the scale, the growth factor is 5. So for 1/10 of a x there, so this will be this answer 5 raised to 1/10. So hope that helps. Let's go to the next one. Okay, this is about the population. The population in a city is modeled by so this is given, and where D stands for the number of decades. So that means, let me draw this. So this is 0, and let's see, there's the 1 decade here. So 1, this is like a decade, let's say. Okay. Then you have 2 decades, and so on. So that means in the beginning, the population was 100,000. So that is 100,000. And this is D stands for number of decades. So this is number of decades. And this one, let's call it uh, it's already given to us PD. So this is population since so many decades. So now this is 1 decade. In between, there are years of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So the question here is given is, what does 0.3 stands for? So this part, right? Now remember, the if you compare this is to the exponential function a naught b raised to x here, the beginning is this. A naught stands for, so what is 100,000? This is 1970. So that means in the year 1970, the population was calculated as, so there were 100,000 people. So that's what that means. But what is 0.3 means? Now, B, the meaning, what does B is the factor, right? B is always 1 plus R, where R is the percent increase, or percent decrease. So R is the percentage. So here it says 0.3. So R is 0.3 means it is multiplied by 100, you get 30, and divide by 100. So you multiply and divide by 100, that is 30%. That means the population is growing. What does this mean? It is 1970 to 1980, in one decade, that means in 10 years, the population is, the B here is, the factor is 1.3, because see this part, this is 1.3, and then it grows by, so it grows by, so the population grows by 30% every a decade. So that's all that means. Now the question is, second question, write an equation F. So this time we have to change to Y years. So that's just, this part is, so Y years. So this is Y years. So F of Y. So the next question is F of Y. So you want to know each year. See this part, this is the year. And you can see there's 1 year, 2 years, 3 years, 4 years, 5 years, 6 years, 7 years, 8 years, 9 years, and 10 years. So how does the formula changes? So it was 100,000 in the beginning, and your rate is 1.3, but because you want there are 10 years in one decade, so we'll have to write t years or y years. So we'll have to write y and divide by 10. Okay? So because if you put y equals 10, you do get back your 1.3, which multiplies. See, that's the 1.3 factor. So let me write it neatly here. So this becomes y divide by 10, and you're done. See, that's how you model the exponential function for this real world. The next question is write expression g, this time you're using g, and c centuries. So what does that mean is how does, so for this, I can't go below, I go up now. So let me write this, go up here. So, so remember for every decade, we saw the b is 1.3, right? And then we have seen that f of y, this f of y, we have seen it was 100,000, which was in the beginning, and 1.3 raised to y over 10. Now, this time, he's talking about centuries. So centuries means what? We'll see. And each century, that means how many years are there, or how many decades are there. So it means, let me draw. So it means, suppose I do this way, starting with decade. So in the beginning it was D and it was Fy, right? Now this one decade. So and I want to write a century. Let's see if this was a century, 100 years, and this is like 100 years is one century, right? 100 years. So you will be having 10 years, 20 years, 30 years, 40 years, 50 years, 60 years, 70 years, 80 years. So this is like 10 years, this is 20 years, 30 years, 40 years, 50 years, every decade, 60 years, 70 years, 80 years, 90 years. So what is that you have multiplied? So this from here, so each time, let's say there was a zero here. So from zero to 10 here, it is 1.3, right? 1.3. So 1.3 times 1.3 times 1.3 times 1.3 times 1.3 times 1.3 times. So you're going to multiply it 10 times. See this? So how does your formula change? Your C, the growth factor. So now I'm going to use G of C. Now G means input is century. So in the beginning it was 100,000, and now your growth factor will be 1.3 raised to 10. So that's going to be 10 because you're multiplying here 10 times, and everything raised to centuries. How many centuries are there? Centuries are there. So this is how. And you can write that too. You can put it in a proper order and write, okay, it's 100,000 multiplied by 1.3 raised to 10c. So, so if I put a one and C is one, like let's imagine put C equals one century, and this will be one, and you get your tens, I see. So and get back the same thing. So hope that helps. Okay, with this I want to wind up. Hopefully this helps all of you. Uh, Make sure you write all these notes, and and of course there are more problems, but we have already done them before. So so let me wind up this unit. So what did we do here? Unit 4 and the lesson 7 is complete. So we have solved at least 5 important problems, and the goal is to write y is in the beginning times b raised to x But then this time the B could be a half life. That means it is half, or it could be double also. So B could be B could be twice double. So that's what we learned for this lesson, and hopefully we'll continue this in lesson number 7, 8. The next one will be lesson 8. So please uh, watch this video, do like it, and write down any comment, maybe if you want, what is that one thing you learned from this, and do share with your friends circle. Okay, so I want to extend my all this video that I made of practice problem. I wanted it to go to all the students because our teachers do not get enough time to do this in the class because we have to focus on the task. Let's see if it is lesson 7. We work with 7.1, 7.2, 7.3, and then cool down. And sometimes we don't get time to complete practice problem, and that's why I'm trying to show this. Thank you so much.